Hi, my name is Dev Harish from Loadstar Sensors. We offer a number of force, torque, displacement, and other kinds of sensor measurements using USB, Bluetooth, Wi-Fi, 0 to 5 volt DC or 4 to 20 milliamp outputs. And our sensors are used in a variety of use cases, and some of them with very high speeds are used for impact force measurements. Now I want to talk about our applications in robotics. Robots are increasingly being used to manufacture things. You hear about the Tesla humanoid robots and Figure Robotics and Amazon's robotics and so on and so forth. So the robots are being increasingly used in close quarters with human beings. And therein lies the question of how safe is it to be around these robots. What if a robot is moving something and it moves its arm and then hits you? What does that impact force look like? At what point will that cause an injury to a human being? If a robot is walking around and lifts its leg up and kicks somebody in the shins, how hard will that hit be? And is it going to break a bone or cause some other injury? So scientists, engineers, and developers are looking to characterize the impact from these robots, measure what the impact is, and then take appropriate actions to protect human beings or add stuff to the robotic limbs to reduce that injury from impact. So to measure that impact force from robotic limbs, we have a solution for you here. This is our classic 8-inch by 8-inch impact force sensor, and we've connected it with our very high speed up to 50,000 samples per second data acquisition system with USB output. So both of these come pre-calibrated for you, and you can just connect it to your computer through a USB connection, and then once it's set up, you'll use our LoadView 1000 HS-10K software to capture the forces. So imagine the robotic limb is going to hit this thing, this object here, right? So this is a robotic limb and this is my hand. And then I can zero out the initial value. And if you want an analog output, you can see that it's at around 0.5 volts of raw DC voltage here. And I can start it for 5 seconds. Now I'll select 10 kilohertz as my data acquisition rate. This is the file that I'm going to send it into to collect data. So let's just say we go here. Okay, so, and then this is the file name. So I'll just say test. Okay, so it's going to append the file names to it every time you take a reading. So let's start. And then I'm going to go 1, 2, 3. So you can see I hit 3 times, and you can see the forces being captured at a very high rate at 10 kilohertz data rate here, because that's what I selected here. You can do it at different data rates up to 50 kilohertz, but the noise might vary and be much higher at higher data rates. So you can see here that the noise is in the plus or minus, say, a few pounds of noise, and my peak force was 94 pounds. So the way I would interpret the data is 94 pounds was my peak force with the uncertainty of, let's say, plus or minus 5 pounds. So that's kind of how you would use this tool to characterize those impact forces. Now using our zoom in tool, you can, I'm trying to find where my mouse is here. There you go. So you can go into the graph and zoom in, and you can zoom in to, say, one of these impacts. So you can see it much better now. So now you can see that it's around, close to 88 or 89, something like that here, the second impact, and you can see the entire dynamic force. Now this particular sensor has been modified to add a spring here that tries to simulate different surfaces of the body, right? So if your pure bone was hitting this thing, there would be a different impact than if this part hits something, because there's muscle and tissue, which is a cushioning thing here. So you can add on different surfaces to this part, and also you can change the spring constants to simulate the different kinds of surfaces or objects that are hitting the robotic arm. So that is up to you. You can change it. You can add something on the top here or change the springs to change the spring constant. So that's kind of how you would use this tool for your test and measurement purposes. I hope I've given you a good look into it. Please contact us at loadstarsensors.com if you would like to learn more about it. Thank you.